All right, so we're doing page 72, 14. What's the next one? 48 and 52. We're going to do all these. They're very similar. Now, this up here tells you your parent function. Anybody remember what that parent function is called? Yell it out. Square root function. And it looks like a what? Swim stroke. So you need to know that stuff. So we are supposed to write the equation for this. So I'm going to draw right here the original function, this one up here. So if I plug 0 in there, the square root of 0 is 0. If I plug 1 in there, the square root of 1 is 1. If I plug 4 in there, the square root of 4 is 2. If I plug 9 in there, the square root of 9 is 3. So this graph goes like this. This is the parent function. So now you need to ask yourself, from the parent function, we're supposed to write the graph, this function for this thing. And we have taken this point that starts at 0, 0, and I believe it has moved. So how did we get from here down to there? Well, what did we do moving? Well, it looks like to me that we are going to go down. How far would you say we're going down if these are going by 2s? Looks like we went down 7, and it looks like we're going left. We're going left 1. So what kind of a shift is it called to go down? What kind of shift is that? You got to be able to describe these. Vertical shift down 7. And then we got a, what kind of shift goes to the left? Horizontal shift left 1. So I hope we remember from our deal that we're going to have the square root of x, because this is a square root and there's going to be an x there no matter what, because all square root of x's look like swim strokes. And if you look, if you go there and you go over 1 up 1, just like over 1 up 1, that's going the same distance. So this is not going to be like a vertical stretch or vertical shrink or any of that stuff. So these two are very similar, except we moved where we started. So what goes in with the x when you have this kind of shift that goes in with the x? Anybody know? What kind? What kind of shift? No, verticals do not go with the x. Horizontals go with it. Now, the horizontal was left 1. And what's the weirdo thing about horizontal shift? The opposite sign. So we must put a +1 here. And then out there by your lonesome is where the vertical shift goes. So right there's the equation. That's it. We're done with that one. That's all I wanted was the equation. So is there a question on that one? Okay, now, again, this parent graph is still the same parent graph for this second one. So it's still going to be a y equals, and I'm still going to have a square root of x something. They're always going to have a square root with the x inside when they're a swim stroke. Now, I believe this 0, 0 thing has gone from here, and it's gone down how far? It's gone down 4, and it looks like to me it's gone to the right how far? 3 to the right. And then there's another weirdo thing. It's not, because it's not in the same direction as this one. What did they do? This is super weirdo. How did they get it to be like that? Yes, ma'am. Well, it has reflected down, right? It's reflected down because it's no longer swim stroke like this. Okay. So I want to talk to you. If I just reflected this down, it would go like this. If I took this one and reflected it down, it would go like that. But this is reflect. This is reflect over the x, because it is upside down. It's reflected over the x-axis. But there's another weird thing. Not only is it just reflected over the x, but now it's no longer going towards the right, it's going towards the left. So how else has it been reflected? That's right, it's also been reflected over the y. So that means this has four different things going on to it. So does anybody remember? Well, let's first do the horizontal and vertical shift. So horizontal was +3, so what goes in here? Anybody? -3. You change the sign. The vertical was down 4, so we got a down 4 over here. Now, what do you have to do to get a reflection over the x-axis? So we got to put a negative out here in front. That reflects it over the x. And does anybody remember what reflects it over the y? a negative with the x. So we got to come in here and make this a negative in here also. Now, that should give us the graph we want right there. Now, that's pretty hard. 4 things is quite a bit going on. Okay. Let's see what else. Oh, that was 14. Let's go do 48 because it's a similar problem. Again, this one now is cubic, not a square root, a cubic. And we want to write the equation for the function represented by each graph. So I'm going to draw on here the original graph. So I don't know if you remember this or not, but if you take 0 and you cube 0, you get 0. If you plug in 1, you get out 1. If you plug in 2, you get out 8. You get out 8. And if you plug in negative 1, you get out negative 1. If you plug in negative 2, you get out 8. So this graph is going something, the original graph goes something like this, the x cubic graph. And I'm putting that 2, 8 there for a reason because they gave me 2, 2. So, has this graph been shifted any? It's the part going through the origin moved at all. Has it gone right, left, up, down, any? No. There's no horizontal, no vertical shift. There's only one thing that's different. Normally it goes to 2, 8, but now it's going to 2, 2. Does anybody know what that is that happened to it? It's a what kind of shrink? Since the y is changing from 8 to 2. Vertical shrink, because y's are vertical. So you got to ask yourself, what did they do to 8 to get it to be a 2? They divided by 4. So when you do this problem, it's going to be y equals, and we still got our x cubed, but we need this to be divided by 4. So that's that number in front is a shrink. So 1/4 multiplying is the same as dividing by 4. That would be the answer to that black graph. That's a little tricky. We got another one over here. Now, this one, again, this same red one is the same parent graph here. What's going on with this one? Anybody know? It's flipped upside down, isn't it? This one's increasing the whole time. This one's decreasing, so it's flipped upside down. That's a reflect over what? It's reflect over x. And I hope you remember we did that a little while ago. So it's reflected over the x. And normally we were at 1, 8, right? I'm sorry, 1, 1, my bad. We were at 1, 1 right here. Went 1, 1 and then 2, 8 like that, right? That was the original. That's a little too far. But now it's reflected down. Instead of being at 1, negative 1, it's now at 1, negative 2. So not only are we reflecting it, what are we doing to that y value? The y value that was right here was 1, 1, but it went from 1 to a 2. So what else did we do besides reflect it? We multiplied by 2. Now the negative part is the reflection. The 2 is the vertical stretch. So we are going to take that original function and the negative flips it upside down. And then the 2 is a vertical stretch, and this would be the equation for the second one. We got one more to do like this. Anybody got any questions? Okay, we got one more to do like this, 52. And now we got one that looks like that thing. Anybody know what that function is? That's an absolute value function. So I'm going to show you what the original absolute value function is. The first value, the first is 0, 0, then it goes through 1, 1, then it goes through 2, 2. It has a slope of 1 going like this. And then the other one, way has negative 1, 1, negative 2, 2, and it has a slope of negative 1 going that way. So what function makes them look skinnier? What transformation makes them look skinnier? Vertical stretch. So I've got to figure out what did change. Well, normally, if I take this, I always go up 1 over 1. Up 1 over 1, because The original graph is y equals the absolute value of x, and there's a 1 up here. So that's why you go up 1 over 1 the whole way, up 1 over 1. But now, if I were to take a line, and I were to take a line and draw it straight vertically right there, that's pretty close. I just moved it over a little bit. But that's kind of a parallel to the y. Do you see 1 now? 1 now has 5 value with it. And the original value was right here at a 1, 1. So can you tell me what did I multiply the y by to get up there? 5. So my new function has a vertical stretch of 5. So I got to stick a 5 in front. And that's the answer. So some of those are very similar to each other. Does that help? How many people with thumbs up feel a little bit better? Okay. Are there any other problems you're going to see off of page 72? Anybody else got any? You gonna be all right? You gonna be all right? Yeah. Okay. Looks like you're struggling.
Oh, no, I'm just zoning out, sorry.
You what? Zoning out, the purple and green bugs got your brain? I thought you were like me and feeling super tired for some reason, because I am. All right. You're done with those. Put your first and last name on them, put period 7 on them, and pass them up to the front. And I'm going to go over the next section. It's over there on that desk. That's where it is always going to be, and you can help yourself to it anytime you need a stapler.